In this video, we'll be going over min stack. So design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So implement the min stack class. So the min stack is just initialize the stack object. We have a push method which push a value into the stack, and then we have a pop method which removes the element on the top of the stack, and top which basically peaks the element on the top of the stack, and then we have the get minimum, which is to retrieve the minimum element in the stack. Let's go over the thought process. So a stack is a last in, first out data structure. The last elements that is pushed into the stack will be the first one to be popped out of the stack. Now, how can we store the minimum elements, or store or find the minimum elements? The brute force approach will be to perform a search on our stack. This will require us to pop all of the elements out of the stack, and store the elements, and before that, and look for the minimum elements. Since we are popping elements out of the stack, we will need a buffer data structure to hold the elements that we have popped out. Then we can push the elements back into the stack after we have found the minimum elements. Now, this approach is not really efficient because we need to create a buffer data structure every single time we want to look for the minimum elements. And also looking for the minimum elements would take us all of n time complexity because we need to pop all of the elements out and then push them back in. So it's 2 times n, which is O of n. So this approach is not efficient because we need to create a buffer class or buffer data structure to hold the elements, which may cost us O of n space complexity. O of n space complexity. And then also, this approach will cost us O of 2 times n time complexity, which is equal to O of n time complexity, due to the push and pop of the elements, or pop and then push of the elements. Now we can create another data structure to hold our minimum elements instead. Now what kind of data structure can we use? We should know that if we do store the minimum elements inside another data structure, when we pop the elements from our original stack, if the popped elements is also the minimum value, we will also need to remove the minimum value from our other data structure here. We should know that the ordering of the minimum elements will be the same ordering as the original stack that we are storing our current elements. This means we can create another stack to save the minimum elements, or to hold the minimum elements. So we can create another stack to hold our minimum elements. Now, if we create another stack to hold our minimum elements, the retrieval of the minimum elements will just be on the top of the stack. So the retrieval becomes O of 1 time complexity. This will allow us, so we can call this stack. We can call this stack 2. This will allow us to retrieve the minimum elements in O of 1 time complexity. So let's implement the code. So we're going to initialize 2 stacks. The first one, stack 1, is keeps track of the original elements. And then we have stack 2, which only keeps track of the minimum elements. Now let's push the elements x into the stack. So if stack 2 is not empty, and stack.peak is greater than or equal to x, this means x is a new smaller element, a new minimum element. So we can push x into stack 2. Then we can push x into stack 1, because stack 1 just keeps track of the original elements. And then we have a pop method. So we're going to pop an element x from stack 1, which is our original elements. And then we want to check if x is currently the smallest elements or not inside our other stack. So if stack 2.peak is equal to x, this means we will need to remove it from our stack 2 too. So we're going to pop an element from stack 2. Now the top method is just we have our original stack of elements, so we can just return stack2.pop or stack2.peak. Stack1.peak is our original elements, and then we peek from it. Now the get minimum, which is the minimum elements on the top of our stack 2, so we can just return stack2.peak. Now let's go over the time and space complexity. For the space complexity for our min stack is O of 2 times n, so we get O of n, where n is the number of elements. This is because of our 2 stacks. And our push becomes O of 1, because we're just pushing elements on top of stack 2 and stack 1, so we get O of 1. Our pop is also O of 1, because we're only popping elements from the top of the stack, from top of stack 1 is top of stack 2, so of O of 1. Our time complexity for top is also O of 1, and our get minimum is also O of 1. Now let's go over the code. So we're going to create our 2 stacks. We have our stack 1, and we also have our minimum elements inside stack 2. Now we want to initialize both stacks. We want to push the elements, the value into our stack, but before that, we want to check if value is going to be a new minimum element. So if stack 2 is empty, or wait, let's see the pseudocode. If stack 2 is empty, or so if stack 2 is empty, or stack2.peak is greater than or equal to value, this means the current element's value is going to be a minimum element, so we're going to push into our stack 2. Then we get stack 1.push val. Now we want to pop an element from the stack, so we can pop the value x from stack 1. Now we want to check if x is one of the minimum elements or not, or if x is the current minimum elements. If stack2.peak is equal to x, then we can pop x out of the stack 2. Now we want to peek the top elements of stack 1, so we can return stack1.peak. Then we can return stack2.peak. Let me know if any questions in the comment section below.